Hi, I'm John West, one of the partners here at Research Affiliates, and today I'm joined by one of my fellow partners at the firm, our senior advisor, as well as a professor at Duke University, Cam Harvey. Cam, welcome.
Thank you.
Cam, today we're going to discuss some of the issues as it relates to cryptocurrencies, the rise of the robo revolution, as well as another related investment that I know you've done a lot of work with is gold as an alternative to fiat currency. So with that, let's get started with cryptocurrencies. One of our most popular talks ever at many Research Affiliates advisor events is your discussion on cryptocurrencies, which I believe is your introductory lecture to your course on cryptocurrencies at Duke. So maybe you can tell us a little bit, being an early advocate of cryptocurrencies, where we are today and how you see that playing out.
Yeah, so let me actually first qualify the word advocate. So actually, I teach a course for the last 6 years on blockchain technology, and that involves potentially revolution in terms of innovation in many different aspects of industry. And one component of that is cryptocurrency. So I teach a course that talks about the hype behind this, and I try to cut through that hype, because I think there's some really good ideas here, but there's also some really bad ideas. So my students, and I do recollect giving the talk at the advisor symposium, so I include a very broad definition of student. So I think that I really try to help them navigate the space, which is a complex space. So let me try to describe what we're talking about and just a little bit of an overview as to where we've been. So number one, what is a blockchain? So it is a distributed database. So a centralized database is controlled by one entity. It resides on a central server, and that entity can actually edit the database. So blockchain is a distributed database. And the graph on the far side, you can see each one of those dots is a node, and each one of those dots has got a copy of the database. So we remove the single point of failure. So it's fundamentally distributed. The degree of transparency is a choice within this technology. And one crucial idea is that this database is immutable. Once you put something in the database, it's there forever. So if you think of like an Excel spreadsheet, we've got 200 rows of data. We can easily go back and edit row 100. So with this technology, we can't do that. Row 100 is there forever. We can add a new row, row 201, but whatever is in the past remains. And it's a very nice way to do this with cryptography, where we divide the database into blocks or sheets. And at the end of each of these subsheets or blocks, there's a fingerprint that is unique to the data in that block. That fingerprint is repeated as the first line of the next block. And that's why it's called blockchain. There's a commonality. The last line is identical to the first line of the next block. And the reason this database is immutable is that if anybody went in to change a block, to edit the data, so you go in and edit row 100, then the fingerprint is altered at the bottom of the block. And it doesn't match the fingerprint at the top of the next block. The network sees this, and given that there's many different copies of the correct block, the network will replace the corrupted block with the correct block, where you get the match, the last line equals the first line. So this, it's a very interesting technology if you think about what the possibilities are. So to have this database that's immutable, it allows us to establish a registry of the truth. And that might be, I own this piece of land, and nobody can edit it. The government can't do it. The bank can't do it. It is set in stone. It also allows us to easily transact. So I can add a row 201, where I sign over my ownership of the land to you, and we're done. So I don't control it anymore, you do, and it's there forever. So this idea of basically verification of ownership of something and the efficient transfer of ownership is one of the main advantages of this technology, but it's controversial. Right? So initially when these cryptocurrencies like Bitcoin came out, they were used for like illegal transactions. And even not so long ago, you've got people like Jamie Dimon says that Bitcoin will eventually blow up. It's a fraud. So when I saw this, I thought it was interesting because, well, Bitcoin's a computer program. Right? It's not a company. There's no CEO, there's no board of directors. It's a program. So how can the program be a fraud? And he took a lot of heat over this remark. We'll have all of the major banks essentially issuing their own cryptocurrency. It makes a lot of sense. It's great for investors because it reduces costs. The speed becomes a matter of seconds rather than days to do transfers. But even within this cryptocurrency space, people have kind of got their head around, oh, there's this thing called Bitcoin. But there's so many other cryptocurrencies. Bitcoin's very difficult to value, extremely volatile. But that's just the first class of cryptocurrencies. The second class is what I call distributed computational tokens. So these blockchains allow you to run a computer program in them. So you can have if-then statements. So think of a derivative payoff. So if the stock is above $100, then you will pay out. So these are basically computational platforms that can do financial transactions. There's also something called utility tokens, and these are actually fairly easy to value. For example, storage. And the basic idea is the following. We've got all of these desktops that have a huge amount of unused storage. So you might have a 2 terabyte drive. Maybe you're using 500 gigabytes. So why not rent out 1 terabyte and you're paid in storage? And then you can sell that storage for US dollars if you want. And there's an active market for this coin called storage. That's STORJ. And on the other side, let's say you want some storage in terms of disk storage, then you can actually go into the network, pay with this token, and this token is directly, you can value it directly because the comparable is AWS cloud service, right? So there's a price for storage on AWS. There's a price that closely mimics that in terms of this technology. So it's distributed storage, and it's a very good idea. There's many other tokens like that. There are security tokens. So this is very simple. Think of the following. Indeed, one of my student projects talked about this. Suppose you want to buy a share of Berkshire Hathaway. That's pretty expensive, right? Think about $300,000 before the correction. So that's just offside. So why not actually create a token that's collateralized with Berkshire Hathaway stock? And then you could buy 25 cents worth of the stock. You can have a diversified portfolio of tens of thousands of assets by having very small pieces. So the last category is stablecoins, and even within that category, there's a lot of diversity. And I showed you JP Morgan's initiative. The JPM coin is a stable coin. It's a coin that is collateralized with US dollars. So that's what I call a fiat collateralized coin. So Facebook, with their Libra initiative, wants to do the same thing. And they're in the unique position of having billions of users just ready to go. There's regulatory issues. Many policymakers are wary of Facebook, but it's basically the same idea as JPM coin. There's coins that are collateralized with natural assets, like gold. So instead of actually holding the gold or holding a gold ETF, you've got a token that represents a certain amount of gold. You've got it's interesting, a stable coin that's collateralized with crypto. So, and that's the Maker DAO DAI coin, which is remarkably stable even though it's collateralized, over-collateralized with other cryptos. And of course, we've got national crypto fiat. We haven't seen these emerge yet, but it is obvious. All of the central banks are working on these digital initiatives. It's just a matter of time before we actually get there.